Good morning, dear students. Welcome to physics class. We are in the second unit, that is kinematics. In this unit, we have learned a few concepts. That is, concept of rest and motion, types of motion, scalar and vectors, different types of vector, triangle law of addition, subtraction of vectors, components of vector, scalar product, and in the last class we have discussed vector product, distance and displacement. I hope you have learned the yesterday's questions, discuss the vector product and its properties, define distance and displacement and differentiate it. Then I said to do some problems 2.10, 2.12 and 2.17. I think you have done. The problems you have to practice in the note. Okay. Let's move on to the today's topic. Today we are going to understand the concept of differential calculus and integral calculus. Differential calculus and integral calculus. Actually, this calculus is the branch of mathematics. Calculus is the branch of mathematics used to analyze the change of any quantity. Analyze the change of any quantity, that is studying the variation of any quantity. You can learn this differential and integral calculus very detailed in mathematics class. But here some basic information and some important formulas we are going to learn. Okay. First, let's see the concept of function. You may have learned the function in mathematics. Consider a function y equal to x square or f of x equal to x square, etc. Isn't it? Any physical quantity is represented by a function in mathematics. Physical quantity can be represented by a function in mathematics. For example, consider the temperature. So we know that the temperature of our surrounding is changing throughout the day, isn't it? It increases till noon and decreases in the evening. So at any time t, the temperature t has a unique value. So mathematically, this variation can be represented by the notation t of t. It should be called as temperature as a function of time. Temperature as a function of time. That means when the time is given, the function of t will give the value of temperature at that time. The time is given, this will give the temperature at that particular time. Similarly, when we are considering one position, a particle is or an object is moving along x direction, can be represented by x of t. And this is called x as a function of time. X as a function of time. Once a physical quantity is represented by a function, we can study the variation of function over time. Once the physical quantity is represented by a function, we can study the variation of function over the time. Consider a function f of x equal to x square, or we can say y equal to x square. Here y is called the dependent variable and x is called the independent variable. Y is called the dependent variable and x is called the independent variable. That means x changes, y also changes. X changes, y also changes. Okay. So now we can understand the variation or analyze the change. If a function represented by y equal to f of x, then dy by dx, this represents the derivative of y. Derivative of y with respect to x. Okay, y equal to f of x, dy by dx represents the derivative of y with respect to x. That means this is the variation of y with respect to change in x. Variation of y with respect to change in x. And this dy by dx, that is this derivative dy by dx, can be defined by dy by dx is equal to limit delta x tends to 0 y of x plus delta x minus y of x divided by delta x, or else limit delta x tends to 0 delta y by delta x. So derivative dy by dx, that is nothing but variation of y. Variation of y in the sense with respect to x. So y of x plus delta x minus y of x. This is one position, this is another position. So the changes. Variation of y with respect to change in x. Change in the particular x value. So this again we can write as limit delta x tends to 0 delta y by delta x. So dy by dx represents the limit that quantity delta y by delta x as delta x tends to 0. Let's see graphically this variation. So this is x-axis and this is y-axis. Consider a particular motion of a object. Let's see that motion may be like this. Okay, and this is a particular point P. So this is x variation, this is y variation. So at a particular x, this is the position of the object. Now dy by dx, how can we calculate? About this point we have to draw one tangential line. Okay, one tangent we have to draw. Then here we can draw a slope. This is the slope. Now this distance, that is the variation in y, that is delta y, and this is delta x. Okay, so dy by dx at a point P represents the tangent to the curve at that point P. You may have learned in the 10th standard calculating the slope m equal to y2 minus y1 divided by x2 minus x1. That only here, y2 minus y1 divided by x2 minus x1. So that changes only we can write as a derivative dy by dx. So in physics, we should know the formulas in differential calculus. Then we can solve the problems. Okay. So derivatives of some common functions used in physics. This formula you have to learn. Function derivative. First one, y equal to x means the derivative. Derivative only we can call it as differential calculus. dy by dx is equal to 1. Y equal to x square means dy by dx is equal to 2x. Y equal to x cube means dy by dx is equal to 3x square. Y equal to x power n means dy by dx is equal to n into x power n minus 1. This is a very important formula. By this formula only we will get these functions and all. Okay. So y equal to x power n. dy by dx is equal to what? N into x power n minus 1. Let's see this. Y equal to x means how can we write? Y equal to x means dy by dx is equal to n into x power 1. So 1 into x power n minus 1. So 1 minus 1. So what is that? 1 into anything power 0 is 1. So 1 into 1, 1. Y equal to x square. X power n means n into x power n minus 1. So dy by dx is equal to what? N into n, 2 into x power n minus 1, 2 minus 1. What is that? 2 minus 1 is 1. So 2x. Similarly, y equal to x cube means dy by dx is equal to 3 into x power 3 minus 1, that is equal to 3x square. So this is the important formula. Y equal to x power n, dy by dx is equal to n into x power n minus 1. Also you should know y equal to sin x means dy by dx is equal to cos x. Y equal to cos x means dy by dx is equal to minus sin x. And y equal to constant means dy by dx is equal to 0. So these formulas you have to learn. So this is given in the page number 63 in your physics book. Okay, let's see once again. Y equal to x, dy by dx equal to 1. Y equal to x square, dy by dx equal to 2x. Y equal to x cube, dy by dx equal to 3x square. Y equal to x power n, dy by dx equal to n into x power n minus 1. Y equal to sin x means dy by dx equal to cos x. Y equal to cos x means dy by dx equal to minus sin x. And y equal to constant. If there is any constant, there is no change. We know that. There is no variation. So derivative dy by dx is equal to 0. Let's see the example 2.19. Find the derivative with respect to t. With respect to t of the function x equal to a0 plus a1t plus a2t square, where a0, a1 and a2 are constants. Okay, one function is given, the derivative of this function we have to calculate. Here the t is independent variable. T is an independent variable and x is a dependent variable. T is the time it goes, but x depends on this time. Let's see the solution. So the required derivative is here dx by dt. Dx by dt, that is equal to dx by dt we have to find out. First write x equal to a0 plus a1t plus a2t square. So dx by dt. Listen here, this first term contains only a0. It does not have the t. It is independent of t. So it is looks like a constant. So constant, when we are differentiating, we will get 0 plus. And here a1 into t. Here the time, the t is there, independent variable is there, and a1 is the constant. So a1 into t. T means y equal to x means dy by dx is equal to 1. So here x is equal to t means dx by dt is equal to 1. X equal to t. So dx by dt is equal to 1. So a1 into 1. a1 into 1 plus a2 into, here t square. So y equal to x square means dy by dx equal to 2x. So here x is equal to t square means dx by dt is equal to 2t. So a1 plus 2a2 into t. This is the first derivative. Similarly, we can calculate the second derivative also. Second derivative means we have to write dx by dt into dx by dt, that is d square x by dt square. Dx by dt means this is the power 1, so first derivative. D square x by dt square means this is the second derivative. So again we have to differentiate. Here now a1 alone, there is no t, so it is constant, we can write 0, plus here t is there, so 2a2 into t means x equal to t, dx by dt is equal to 1, so 2a2 into 1, so the answer is 2a2. Students, first time this is little difficult to understand. When you are learning in mathematics, it is easy. And here, try to do this problem using the formulas. Okay, you have to understand first derivative means only one time we have to do the differentiation dx by dt. Second derivative means two times we have to do the differentiation, that is d square x by dt square. So here the function is given as x a0 plus a1t plus a2t square. This a0, there is no t term, so we can consider this as a constant. So when we are differentiating the constant, the formula we have learned, it is 0. And here the t is there. So a1 into the t when we are differentiating, that is dx by dt equal to 1. N into x power n minus 1 formula. And here a2 into t square. So here also a2 into t square n into x power n minus 1 means 2 into t power 2 minus 1. So 2t. So answer is a1 plus 2a 2t. Again, one more time we are differentiating, we will get 2a2. The next one is integral calculus. Okay, integral calculation. What is meant by integration? Integration is basically an area finding process. Integration is basically an area finding process. Okay, finding area, you have learned many formula for area for different shapes, isn't it? Area of square, area of rectangle, etc. Here, certain shapes we can find the area directly, but irregular shapes and all, we cannot find the area directly. Let's see the example. This is x-axis and this is y-axis. Here, one function we are considering. This is A position, this is B position. This is the variation. Okay, this is the variation. Now, this is the point C. So we can consider the function as f of x is equal to C. Okay. Now the area of this one, how can we calculate? It looks like a rectangle, so we can calculate very easily. Regular shape, isn't it? This is the area. The area of the rectangle is given by length into breadth. That is nothing but this distance into this distance. Am I right? Area, we can write it as length into breadth. So here the length is this distance. This distance we can write as b minus a into this height. That is into C. This is for regular shape. We can find very easily. Next, consider the irregular shape of the curve. This is x, this is y, and this is the initial position, this is the final position. Now the curve may be like this. Now calculate the area of this curve. So we can consider this is the A position and this is the B position. So this is the function f of x, the variation. Okay. So what is the area here? To find the area of this irregular shape of the function f of x, we have to divide this area into small rectangular strips. small rectangular strips. Then we have to add all the areas of rectangular strips. That is giving the area under the curve. Listen here. This is the curve. Okay, this is the position A and this is the position B. Now I said we have to consider the small rectangular strips. So consider this as x1, this is x2 and this is x3. Okay, so this is the function f of x. So this we can consider as f of a. F of a. Now this is the function f of x1. Similarly, this is f of x2 and so on. Okay. Now here this distance we can consider as delta x. Delta x. Okay. So here this is f of x3, etc. Now this is the rectangular strips. So this is given by the area A equal to f of A in delta x. That is, this is one rectangular strip. So length into breadth, f of A into delta x plus f of x1 into delta x. F of x1 into delta x, this delta x, plus f of x2 into delta x plus f of x3 into delta x plus f of b into delta x, where f of a is the value of function of f of x at x equal to a. F of x1 is the value of f of x for x equal to x1. For x equal to x2, f of x2 is the value of function, and so on. So as we increase the number of strips, the area becomes more accurate. When we increase that is small strips, when we are considering, the area becomes more accurate. Suppose we are considering the curve is divided into n number of strips. N number of strips. Then the area under the curve is given by A is equal to sigma I equal to 1 to n Fn of xn delta xn. See here. So we have to add all the rectangular strips. So n number of strips are there. So many number of strips. Consider n tends to infinity. Is it easy to add all the infinity rectangular strips? No, isn't it? So when n turns to infinity, this sum becomes integral. This is actually sigma means summation, adding all those things. So the sum tends to integral. Sum becomes integral. So we can write A equal to integral a to b f of x dx. Okay. So this is the integration function, integration process. Integration means the symbol we will denote by means of a long S. This is the integration symbol. Differentiation means we will use the term d by dx. This is for differentiation, this is for integration. Okay. So this integration will give the total area under the curve f of x. Integration will give the total area under the curve f of x. Listen, relation between summation and integration. So area integral, you have to read like this, integral a to b. This is from limit, this is to limit. From where to where. Okay. So integral a to b f of x dx is equal to limit delta x tends to 0 sigma I equal to 1 to n f of xi delta x. That means we are adding n number of strips function area, that is given as summation. When we put the limit in that delta x tends to 0, that is n tends to infinity, we can write this in the form of integration. Okay, here you have to learn some formulas from the integration. Anyway, you should know that integration means this one, differentiation means d by dx. Let's see some formulas in the integration. See the important formulas in the integration. Integral dx is equal to x. Integral dx is equal to x. Integral x power n dx is equal to x power n plus 1 by n plus 1. This is the important formula. Okay. Integral x power n dx is equal to x power n plus 1 by n plus 1. And integral 1 by x dx is equal to log x or ln x. Integral cos theta d theta equal to sin theta. Integral sin theta d theta equal to minus cos theta. So these are the formulas you have to learn. In the differential calculus and integral calculus, you have to know the concept, and in physics you should know the formulas. So your study portion is only the formula in this calculations. This integration formula is given in the appendix page, the last page of the book. Okay, so learn the formulas from differential calculus and integral calculus. See one example. Find the integration of x square dx. So what is the formula, general formula? Integral x power n dx is equal to x power n plus 1 by n plus 1. So integral x square dx is equal to x power n equal to 2. So 2 plus 1 by 2 plus 1. So we can write integral x square dx is equal to x cube by 3. So like this, when we are doing the problems, you can understand very well. Okay. Listen some examples from physics. Work done. The work done by a force f of x on the object, move it from A to B. Work done means force into displacement, isn't it? Force into displacement. So we can write work done equal to integral A to B f of x dx. That is, the object move it from point A to point B. Point A to point B. So work done equal to f of x, integral A to B f of x dx. I said integration is an area finding process. Let's see this figure. This is the displacement. This is the point A. This is the point B. Okay. Displacement along the x direction, force along the y direction. This is the function f of x. So here, what is the work done? Nothing but area under this curve. Area under this curve is known as the work done. Right? The next one, impulse. Impulse is given by the force in the interval of time, short interval of time, is calculated between the 0 time to time t1. So impulse usually we will denote as I. I is equal to integral 0 to t1 f dt. The impulse concept you will learn in the next chapters. So impulse is equal to force into displacement, that is force into time. Force into time. So I equal to integral 0 to t1 f into dt. From the initial time 0 to particular time t1. F into dt. So in the graph, this is time is taking along x-axis, force is taking along y-axis. So here this is the 0 time. At t1, this is the function. So this area gives the impulse of this graph. Okay, impulse is the area under the function f of x of t. So students, in this concept you have to learn page number 63, the formula, function and the derivative. For integration, you have to see the appendix page, appendix 2.2, some important formulas are given. Here, formula for differential calculus also given. So few formulas try to learn. Let's see few more concepts. First one, average velocity. Velocity, already we have learned velocity means rate of change of displacement, isn't it? What is meant by average velocity? Average velocity is defined as the ratio of displacement vector to the corresponding time interval. Ratio of displacement vector to the corresponding time interval. So we can write average v vector equal to delta r vector divided by delta t. Delta r vector divided by delta t. It's a vector quantity. So consider a particle which is located initially at the point. Here P having the position vector r1. This is x-axis, this is y-axis, this is the position of the particle, initial position of the particle. After the time interval t, the particle is moved to the point Q. Here the position vector we can draw as r2. So now what is the displacement? This is the displacement. So displacement vector is delta r vector equal to what? r2 minus r1. r2 minus r1. So from P to Q the particle is moving. Here the average velocity V average can be written as delta r divided by delta t. Delta r divided by delta t. The direction of the average velocity, since it is a vector quantity, the direction of the average velocity is in the direction of delta r. The direction of displacement vector delta r. The next one, average speed. Average speed, same, it is also defined as the ratio of total path length travelled by the particle in a time interval. Total path length travelled by the particle in a time interval. So average speed is equal to total path length divided by total time. Here an important point, average speed is greater than the magnitude of average velocity. Average speed is greater than the magnitude of average velocity. For this, just try the example 2.20 from the book. The next one, instantaneous velocity. Instantaneous velocity or simply velocity. What is instantaneous velocity? Instantaneous velocity at an instant. At an instant, t is defined as the limiting the value of the average velocity. Limiting the value of the average velocity delta r tends to 0. Or simply, it is the rate of change of position vector. The velocity is defined as, or velocity is equal to the rate of change of position vector with respect to time. So velocity is a vector quantity. So v vector equal to limit delta t tends to 0 delta r by delta t. Rate of change of position, r is a position vector. Position vector. So that is equal to dr by dt. We can write this is in the component form. In component form, v vector equal to dr by dt. So we can write d by dt of position vector is xi cap plus yj cap plus zk cap in 3 dimension. So we can write dx by dt I cap plus dy by dt j cap plus dz by dt k cap. Here dx by dt is the bx, x component of the velocity. This is vx. dy by dt is the y component of velocity, vy. dz by dt is the z component of velocity, vz. Okay. So now the magnitude of velocity v is called speed. Magnitude of velocity v is called speed. So what is that? V is equal to square root of vx square plus vy square plus vz square. The magnitude of velocity v is called speed, that is v is equal to square root of vx square plus vy square plus vz square. Here the speed is a scalar quantity. Speed is a scalar quantity. But the unit of speed is same as that of velocity, meter per second. So listen, speed and velocity. Speed means the distance per unit time. Distance per unit time, or we can say rate at which the distance covered. Or we can say magnitude of the velocity. Magnitude of the velocity, that is speed. Speed means per unit time. Velocity means rate of change of displacement. Speed is a scalar quantity. Velocity is a vector quantity. The unit of speed is meter per second. The unit of velocity is also meter per second. Okay. Students, try to solve the example 2.22. That is, the velocity of three particles A, B, C are given below. Which particles travel at the greatest speed? Okay. So, first one, VA vector is given, VB vector is given, VC vector is given. They are asked to calculate the speed or which particle travels at the greatest speed. Okay. So, the solution, speed means nothing but the formula is what? V is equal to root of Vx square plus Vy square plus Vz square. Isn't it? So, Va square equal to root of 3 square plus of minus 5 the whole square plus 2 square. So, we will get root of 38. Speed of B, calculating by square root of 1 square plus 2 square plus 3 square, root of 14. Speed of C. So, root of 50. So, the particle C has the greatest speed. So, root of 50 is greater than root of 30 is greater than root of 40. Similarly, try to solve the problem 2.23 and 2.21 also. Next one, momentum. This also you have heard in the lower classes. Momentum, or simply we can say linear momentum. Linear momentum defined as the product of mass and velocity, isn't it? P vector equal to m into v. It's denoted by P vector equal to m into v. This is also a vector quantity. So, the direction of the momentum is in the direction of velocity. Direction of momentum is in the direction of velocity. This also we can write in the component form. Px I cap plus Py j cap plus Pz k cap equal to m into Vx I cap plus m into Vy j cap plus m into Vz k cap. So, Px is the x component of momentum, which is equal to mvx. Py is the y component of momentum, which is equal to mvy. Pz is the z component of momentum, which is equal to mvz. And it has a unit kilogram meter per second. Mass unit is kilogram, velocity unit is meter per second. Today we have learned differential calculus and integral calculus. There we have to learn the formula alone, and we have discussed average velocity, average speed, instantaneous velocity, then momentum. Okay, you have to do the examples. This is homework for you. 2.20, 2.21, 2.22 and 2.23. Students, so far we have completed 1.5 lessons. Try to learn the book back questions. Lesson 1, all the question answers, short answers, 5 short answers and long answers, 5 long answers. Then lesson 2 also, almost 8 short answers and 2 long answers we have completed. Try to learn all these questions. Thank you, students.